All right, good morning. I had told you in an email that I would post a video, and I actually made that video and attempted to post it, and I'm not sure what happened. So I've regrouped, and I'll put this one on YouTube and post the link, but you'll have it. The reason I'm telling you all of that is because I completed this handout as I was working that video, and I'm not going to rework all of these. I'm going to work the ones that I did originally. So what's posted on Canvas will be a blank copy of this, and then also this completed copy, so that'll give you some other practice problems. So had a couple of you email me asking about needing some more help with proving trig identities, and I'll be honest, it's one of those things that lots of people have issues with. It gets to be really tricky, and we've got to remember all of those identities that we've talked about. So before we left for spring break, and then of course we've been out forever, we made a list of these fundamental identities. These are on page 197 of your textbook. And so you need to know from memory all of these. And listen, they come up all the time in every other class. I can't tell you in Cal 4 and differential equations how many times this Pythagorean identity has come up. It just happens all the time. So be familiar with those. I realize now, taking things on the Pearson site and on Canvas, I get you're going to have those things in front of you, but please don't cheat yourself as you're working. Okay. So one issue with proving trig identities are the steps or the rules to follow, and listen, I really can't give you any, unfortunately. What I will give you is some suggestions. I'll call them some guidelines for proving identities. And the first one is the only one that for me sort of kind of borders on a rule. We want to work with only one side, which means I want you to leave the other side alone. Once you decide which side you're going to start manipulating and making substitutions for, great, then don't touch the other side at all. Well, how do I decide which side I'm going to work with? Typically, we work with the more complicated side. Work with the more complicated side. It's going to be easier to make complicated things simple than simple things be complicated. So if I just glance at number one, which will work in just a moment, the left-hand side is more complicated. So that's the side I'm going to work, which means I'm not going to touch, the secant at all. Okay. If you just don't even know where to start, then my suggestion is to make everything a sine or a cosine. All 6 trig functions can be written as a sine or a cosine or a combination of sines and cosines. I'm not telling you to do that every single time, but it's often a good thing to at least try. And the other thing that comes to my mind, if you see things like sine squared of something, cosine squared, tangent squared, especially in 1, then my suggestion is to think about the Pythagorean identities. Now remember, there were 3 of those that are on that page, but in our notes before we left for spring break, we also wrote some alternate versions of those. So you want to be familiar. Again, you don't want to just be familiar. You want to know all of those versions. So we want to use and pull from all of that stuff to solve some problems here, beginning with problem number 1. Number 1, we want to show that tangent times cosecant is equal to secant. And so we've already said that we'll work with the left-hand side because it's the more complicated, but we don't ever want to lose sight of the right-hand side. The right-hand side says secant. So what are some things that I could turn into a secant? Well, the only thing that comes to my mind is 1 over cosine. So I'm telling you that to say that if I can find a 1 over cosine on this side, then I'll have my solution to that problem. So I don't have a cosine at all right now, do I? So I think the best thing to do is maybe just to make everything sines and cosines. So tangent can be written as sine over cosine, And cosecant can be written as 1 over sine. So notice how I'm carrying along that right-hand side each time, too. I'd like for you to do that. So my sines divide away. So I'm left with a 1 over cosine, which is exactly secant. So that proves that identity. And look, I almost did it just right now, but we're tempted to kind of box in that like we're used to, like that's an answer. It's not an answer. The whole thing is the answer to that problem. Look at number 3. It's a similar idea. I want all of this, because this is the more complicated side, and at the left-hand side, I want all of that to be equal to a 1. And the only way to get a 1 when I'm multiplying and dividing is for everything to cancel out. So again, if I want things to cancel out, let me again try to make everything sines and cosines. So secant is the same as 1 over cosine. These are alphas now. Sine already is a sine or a cosine, so I'll leave it alone. And then tangent is sine over cosine. But again, that's lots of things that play there. I'm not seeing right off anything that will cancel. What I am seeing is a fraction divided by a fraction. And I know that to multiply fractions, we can multiply by the reciprocal. So the reciprocal of that red fraction is cosine alpha over sine alpha. And now, since everything is being multiplied, I can cancel. I can cancel out cosines. I can cancel out sines. When everything cancels, remember we're canceling things to 1. And so that's a relatively easy identity. I want to show you a couple of other ones. Number 4. Number 4, again, I'm wanting things equal to 1. And, you know, honestly, we're tempted to distribute when we see stuff like that, which is not a bad approach. I tell you what, though, this parentheses, I'm recognizing that as an alternate form of a Pythagorean identity. Namely, 1 minus sine squared is cosine squared. By the way, don't get in the habit of just changing everything. For instance, back on number 3, I changed most everything, but I left the sign alone. You want to kind of look big picture for a moment and just kind of begin to get an idea of some things to be able to accomplish and do. So I did change that. And then secant squared, well, we've seen that a couple of times already. That's the same as 1 over cosine squared. And those do cancel out. And there's a solution. It occurred to me there's a second good way to do that problem. So that's not going to be on the completed one that I posted, but it's on this video. Let's say that I did want to distribute everything. So secant squared times 1 is secant squared. I'll say r, because this is another way. And secant times sine is exactly that, secant squared times sine. And then look right here, secant squared is the same as 1 minus cosine squared. And so I'm left with sine over cosine, which is exactly tangent squared. And so here's another alternate version of a Pythagorean identity. Secant minus tangent is exactly 1. So there's another correct way to do that problem. I think the way I started with is a much easier approach, but it's not to say that it's the only one by any means. Okay? And then let's look at number 7. And let's don't do number 8 at all. I can't remember. There used to be a sign error on the handout, and I can't remember if I ever fixed it or not. So just forget number 8. So number 7, one side is about as complicated as the other. I think just because maybe I'll work with the right-hand side. The solution that I did earlier that I'm going to post, I worked with the left-hand side. So 2 different but correct ways to do the problem. As I'm looking, maybe I don't want to mess with this 2 sine squared at all because I have a sine squared on the other side. What I'm needing, because remember I'm working with the right, what I'm needing is a cosine squared. I think what I'll do is make a substitution for 1. 1 is exactly equal to sine squared plus cosine squared. And this minus 2 sine squared is this minus 2. Well, then what I've really got now is some like terms. 1 sine squared minus 2 sine squares is a minus 1 sine squared and a cosine squared, and that proves that identity. I've made them look identical. Okay, so just some comments. I'd like for you to work number 2 on this page if you need some more practice. Number 6 is a really easy problem. Number 5 is relatively easy. I would think about distributing and see what you can come up with that. And then number 9 and 10 do those. They're a little bit more challenging, but they'll give you some solutions to look at. Okay.